Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I will be calculating the values for a DC parallel circuit from the Chapter 7 math handout, problem number 2. I will be taking the known values from the Chapter 7 math handout. Let me show you the handout. Alright, so here's our Chapter 7 math handout. You can see on problem number 2 the values I'm given. This is a basic combination circuit, so I'm given all the values of my resistors. I have a total voltage of 18 volts and 3 resistors listed. I will leave a link in the comments section below this video so that you can print you a copy of the Chapter 7 math handout if you need it, or you can just pause the video and write down the values on the Chapter 7 math handout. So you may want to pause the video now and write down numbers 1 through 7 and number 8 we're going to save for later, and it will not be on the Canvas Chapter 8 math handout answer sheet assignment. Problem number 8 is not on the assignment anyway, so we're just going to worry about 1 through 7, and we'll do number 8 in person. All right, so I've taken my values from the number 7 Chapter 7 math handout, problem number 2. All right, so I have the value of all my resistors, and I have my total voltage. So since this is a basic DC parallel circuit and not a random unknown, the first step will always be in a basic DC parallel circuit to find RT. And the way that we find RT, as you see listed here, is the reciprocal formula. Now I've taken this from the rules for parallel and series circuits, and I just clipped this out and put it on the screen for you to be able to see it. And you see here that it says REQ, and I have RT. So just be aware that REQ, which means equivalent resistance, and RT are used interchangeably. And VA, it actually says VA on the circuit, VA and VT are used interchangeably. So to find RT, I'm going to use reciprocal formula. It's 1 over under 1 over under 15K. Scroll over, hit plus 1 over under 22K plus 1 over under 30K. It equals, I hit engineering, and my total resistance for this circuit is 6.88 ohms, rounding the second number after the decimal place. All right, so I'm going to try to save power till last anytime I can, and in this case I can. You always can leave power till last on a basic DC circuit. So now that I've got 2 out of 3, I can find current using Ohm's law. I am looking for the I value, so down here if I cover up the I, you can see that the blue was I. So he's covered it up with his finger, and that shows us that if I'm looking for I, it's going to be V divided by R. So my V is 18 volts over 6.88 times 10 to the third ohms. It equals hit engineering. So this tells us that we have 2.62. Rounding the second number after the decimal place, 2.62 milliamps for our IT. Now each one of our currents is going to be different in a parallel circuit. So what can I do next? Well, if you know your series parallel rules, you know that you can go ahead and write 18 down in every voltage blank, because voltage stays the same in a parallel circuit. So this tells us for this parallel, we can go ahead and write all of our voltages down. And we will have to calculate each one of our currents, because current does not stay the same in a series circuit. It adds up, as you see right here on the rule. I'm sorry, it does not stay the same in a parallel circuit. It does stay the same in a series, but in a parallel, each one of our currents will be different. So I1 is going to be the 18 volts divided by 15k ohms. So 18 over 15 times 10 to the third equals 1.2 milliamps. Next, I just changed the bottom number to a 2 for 22k ohms of number 2 right here. And hit engineering, and that gives me 818.18. And look at here, it's microamps, not milli, but micro, -6. I can already tell that my next answer is going to be a micro, because I've got 30k ohms in that one with the 18 volts. So again, I'm covering up the I in my circle, and that tells me in order to find I, it's V divided by R. This is why you should write this circle down on your scratch paper for a test. You should write that circle down and you should use it. Put your finger over whatever you're looking for. As long as you've got the other two equations, other two values, you can find the third. All right, so 18 volts divided by 30k ohms. So I'm going to change the 22 to a 30. $30k ohms, 18 volts. What's my current going to be? 600 microamps. So if you want to check your work, you can make sure that 600 micro 8.18, sorry, 818.18 microamps and 1.2 milliamps. Add those all together and they should come up to the 2.62 milliamps. Now it might be off by a very small amount of rounding, but that's okay as long as you're close. All right, so finally we can do power. PT is equal to IT times VT. So I'm going to put my voltage in there first where I don't have to keep changing it. So we have 18 volts times 2.62 milliamps. Giving us, well, I must have did something wrong. 18 times 2.62 times 10 to the negative third milliamps equals, hit engineering, 47.16 microwatts. Power is measured in watts. All right, I'm going to leave the 18 in there, and I want to change the current amount to the 1.2 milliamps. So I scroll up, get rid of this number, keep my 18 volts. P is going to be equal to the 18 volts times 1.2 milliamps. Negative third equals, hit engineering, 21.6 milliamps. I'll leave the 18 volts in there, and I'll change this number here to 818.18 times 10 to the negative 6 equals, heat engineering, 14.72 microwatts. It must have rounded up, or I did it a little bit different last time. So see, it says 14.73 is my answer. The calculator says 14.72. Even if you were to do rounding, you wouldn't round the 2. So we've got two different answers here. When you get two different answers that are that close on the test, just show it to me and I will give you credit for it. And for the answer, when you get a really long number with a bunch of numbers after the decimal place, you're just going to write two numbers after the decimal place. And you're going to round that second number. Okay, next I need P3, which is going to be 600 microamps times 18 volts. So I've got my 18 volts in there. I'm going to go and delete that current amount, and I'm going to put in the 600 times 10 to the negative 6 equals, heat engineering, 10.8 milliwatts. So now that I've done all my calculations, I see the three problems here. I just put the values that I calculated down below in these blanks, and these will be the ones I'm looking for the Chapter 7 Canvas answer sheet assignment. I do recommend that you do all of these calculations on paper first. There's only 7 of them. You don't have to do number 8 right now. I'll show you that when you come to class. But I would write all of my answers on paper in my notebook first and work all 7 with all of your answers in your notebook. Once I've got everything worked out on paper, then I would take those values and put them into the Canvas answer sheet assignment. If you try to leave your computer open while you're doing the math, you could have a power outage and lose that data. Anything could happen if you take a long time, 2 hours or 3 hours between the time you open the assignment and the time you close it. Anything could happen and you would lose your work. Let's say you're halfway through with it and the power goes out and you lose power. Well, if you was doing that on paper, that would be no problem. So work it out on paper and then put the answers into the Canvas answer sheet after you have worked all of these on paper first in your notebook or whatever. All right, thank you.